These are the three different types of triggering methods which are used to commute, which are used to switch on your thyristor. As name says, it is resistor triggering. We are going to have a resistor which will take care of switching on and switching off your thyristor over there. Means using the resistor, using the variable resistor, we are able to apply the current to the gate of the thyristor. Using the variable resistance, we can able to apply the current to the gate of the thyristor over there. So even though we are having input as AC here, even though we are having input as AC, the AC is not directly going to your thyristor. That is the problem we are having. You know what I said? If it is AC input signal is there, if you apply that one to thyristor and the current will keep changing over the positive to negative, so thyristor will go to on state, off state. That is what the statement. But the AC signal what we are having, that is not directly given to the thyristor. Through a load we are giving over there. Load is like a blockage. It is blocking your input signal to the thyristor over there. Let me rewrite the circuit so that I can go for explanation how exactly it's going to work. So it is R triggering, or resistor triggering, we call this one. We have input signal, we have a load, and the load is being connected to your thyristor, and thyristor is directly connected to your thyristor. We are going to have a diode. This is very important. Diode is very important. We have R minimum, we have R load, and also we have a RB. Will you get it? Positive, negative, anode, cathode, and we are going to have anode, cathode, and gate. This is your gate. We are going to have the IG. We are going to apply the IG. Positive, negative. This is the load. Positive, negative. We are going to have EL. And this is your ES. That is supply voltage. Don't enter, don't stop there, don't stand there, begin. Settle down fast. Concentrate here. Now, the circuit I have written. Static circuit, there is supply, and we have to know how exactly the circuit is going to work. So we have to know each and every element, how it is functioning in our circuit. So that's very, very important in our electronic circuits. All the electronic subjects, you should step by step, you should verify. Even when you are doing conducting in the lab also, even though circuit is an number of elements, right from the input, you should keep on checking what is the value at each element over there. As soon as I want to measure the output voltage, because rectifiers you have done that one. Output voltage, so you are supposed to measure it. Okay, you have to measure the current, you have to measure the voltage. Not by rectifier, good by rectifier, whatever you have done that one. And even scenario. Sometimes what happens, I am not getting the output voltage properly. So don't sit idle. You are not supposed to sit idle. You should not say that the output is not coming. Sir, I am not getting the output. It's a component problem. Component connection is not correct. All those issues will be there. So what we need to do? We should measure at each element. At each element, whether input is coming properly. Sometimes whatever we have done, the result is not going to the circuit. Because they are not grounded properly. There is positive and also ground point should be there, negative should be there. Sometimes we forget to connect the ground. Sometimes we forget to connect the ground, so we are not getting the power supply data. Simply we blindly leave the ground and we there go and check the output, we are not getting the relevant output. So my issue is, my suggestion is, kindly check the voltage at each element, or kindly check the current passing through each element over there, so that we can easily or can completely come to know what exactly the circuit is doing. What exactly the circuit is doing. So I can measure you low voltage, is EL. I can measure the voltage across the thyristor. I can measure the voltage across the diode what we are having. I can measure the resistance. This is R minimum will always, and this is R gamma. Gamma indicates a variable resistance. Gamma indicates a variable resistance. By varying the resistance, I am varying the current flow through the diode, and that will indicate that whether the current is increasing to the thyristor or current is decreasing to the thyristor. Based on the current flow through the thyristor, we can come to know that one whether the thyristor is triggered or thyristor is not triggered. Okay, so how to do? I am not having a constant current flow. If this resistance is constant, current flow is also constant. Since I am varying the resistance over there, obviously as resistance increases, current flow decreases. Correct? As the resistance increases, current flow decreases over there. So if I am increasing the resistance here, flow of the current, okay, decreases here. Once the flow of the current decreases, so it's going to become open circuit. Once it is open circuit, current will not go here. You will not get the current. Once the current is not coming, thyristor is not on. So once the thyristor is not on, you are not going to get the triggering angle. Firing angle will not come. Thyristor will not go. So your output will not be there. So this is the concept. Yes is on, load is there, and if this load is correct, everything is okay. R minimum and R gamma will be functioning. If R minimum and R gamma is okay, somewhat is okay, it allows the current to the diode. Diode will be in forward bias. Once the diode is in forward bias, it will supply the current, and current will keep increasing. It should increase until the minimum gate current. IG minimum, we'll say IG minimum. I'll show you that how exactly it's going to work. So IG minimum, it should exceed. Then only once it exceeds the IG minimum, then only the thyristor conducts. Okay, fine. Listen, last bench. A circuit, very simple. Input is ES. ES will call this one. This is the ES, which is a oscillating, a sinusoidal. But we are having a load, very high value of the load, we are going to have that one. That is restricting my current flow, or my voltage drop is more over there. So initially my input will be like this. This is my input. Because it is ES, and I have the maximum value, that is E max. This is 0, this is E max will have input, and this is respect to time. Now similarly, I need to measure what is the value of EL, the load, the voltage across the load. The voltage across the load I need to measure over there. So initially what happens, I'm not going to get any voltage across the load. This is 0. I will be having that's what has been given. This is with respect to EL. The voltage across the load. The voltage across the load. What happens? As soon as we give the power supply, it will not go directly, it will not pass through the load over there because the resistor is open circuit. The resistor is not working. Plus the resistor has to work. Once the resistor is work, then only your load will get some voltage across that one. The resistor itself is not working, so load voltage is not in a position to measure that one. They are not in a position to measure that one. See what you are? Only open circuit is there. So here in the measurement is power. We cannot measure the voltage across the system. Since the circuit is not complete, circuit is not complete. The resistor is open. Since the resistor is open, it is not in a position to complete the circuit. So you are not in a position to measure the voltage drop across the load over there. So voltage drop is 0. Voltage drop is 0. When it is going to increase, when it is equal to that one, as your current increases, as the current increases. So here, this is an open circuit. This is an open circuit. But it can pass through that area. Listen here. I am giving an input. It is passing through the load. Since the thyristor is open circuit, you are not able to measure that one. But there is one more direction is there. The current passes through R minimum and R gamma. So R minimum and R gamma, it is coming. It is getting the data. But it should generate the required current. What is the required current? To trigger this one. So it takes some time. It takes some time to generate that current over there. That is what the time which is lagging here. So this is lagging time. This time, why this time is the resistance what they are having. They are resisting the flow of the current instantly. It is consuming some part of the time. After the time only, your diode will conduct, diode will send the current, and current will be triggering your thyristor over there. Initially it happens, initially it will not work. After some time only, maybe in terms of the microseconds or nanoseconds, it's going to work over this. That is why this particular delay we are going to get. A delay will appear. This delay on board, it is very big in size, but when you practically do that one, it will be in terms of the microseconds. It will be in terms of the nanoseconds. Because nowadays we are going to get all the sophisticated devices, they will come and measure in terms of the nanoseconds. A small delay will be there in terms of the microsecond nanoseconds. So once your diode conducts at some part of the resistance, it will allow the current. Once the diode conducts, this IGs keep increasing. IGs keep increasing. IGs initially 0. IGs keep increasing. Once it increases to its minimum value, then the thyristor is going to conduct. Since the thyristor is conducting, we are going to get the load voltage which is similar to the input voltage. What are the input voltage we are giving? We are able to get the same across the load. But it's charging, inside it's charging, triggering angle. After some time, your input voltage is going to 0. It's going to 0. You can say, raise a question here, sir. At this point, till this point, we are not getting the current. We are not getting the load voltage. And as it increases, example. Kindly concentrate. At 0, I'm not getting. Once your diode has become positive, it is taking some time. Then at that time your input voltage has reached this value. Input voltage has reached this value. So after that, whatever input voltage is there, the same voltage will be appearing on the load. Accept it. It is reached maximum, it is reached maximum. Then input voltage obviously maximum is the something is decreasing. It is decreasing. So you are decreasing. Whatever is happening with the input, the same thing is happening with the output also. That is load voltage. Now once it comes here, you can raise a question saying that one, sir, input voltage is already low. Okay, so here why it is not going directly here? Why it is not going directly here? So as it is happened to the beginning of your thyristor, why it is not happening at the other end of the thyristor? Means when it is going to negative. Because discharging takes place. It is discharging. At the time of discharging, it consumes the time. So as it is keep on discharging, the same thing is going to keep on decreasing over there. Don't expect instantly it comes like this. Instantly it will not come. Okay? So totally getting disturbed. Even though many times I'm telling don't speak, people are keep on talking. Solpanaruve, ನೀವು ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಅಂತ ಇದ್ರೆ ಒಂದ್ಸಲ ಹೇಳಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. ಪದೇ ಪದೇ ಹೇಳಿಸ್ಕೋಬೇಡಿ. Don't make me to repeat the same thing. Kindly concentrate. This is very important. Why it is not coming down directly? Because charging and discharging. Discharging takes place when it is discharging. It is going through along with the diode. Once it reaches, then your load voltage will become zero. Because it is negative, thyristor is going to not conduct over there. Diode will not conduct. Obviously, diode will not conduct. Diode is not working. Diode is reverse bias. Definitely, it will not send the current over there itself. So once it is not sending the current, it is going to become open circuit, you cannot send the voltage, is not allowing a position to measure the load voltage as so similarly, the same thing has been explained and it will go like this. Once again, once it becomes positive, the same thing is going to repeat. But when you want to measure the voltage across the thyristor, voltage across the thyristor, you have to measure that one. The voltage across the thyristor is measured like this. Up to the triggering. Up to the triggering, you don't detect the voltage across the thyristor. Okay, you're able to measure that. Once it comes, then it's going to become zero. It becomes zero, then correct. The same thing will repeat over. In the negative, it's only you're able to measure the voltage across the because more drop will be there. More drop will be there as input is there, the same thing will repeat here. This is your VAK. Voltage across the thyristor voltage. Voltage drop across the thyristor. The same thing has been explained theoretically here. What happens? This is the simple method for triggering. R method, that is R triggering is the simple method for triggering your thyristor. SCR gate current is supplied by an AC source, that is ES. Voltage ES through the R minimum, R gamma and the series diode D. So the voltage will pass through this one. Voltage is supplied to R minimum, R gamma and also diode. How exactly it's going to operate? As ES goes positive, the SCR becomes forward bias from anode to cathode. Yes, but it will not work until your IG is going to become IG minimum. That's what I am telling you. Even though I have supplied the voltage until your SCR conducts, they're not going to get the voltage across the load itself. As ES goes positive, the SCR becomes forward bias, but we don't have the current, IG current, so it will not get the voltage until its gate current exceeds IG minimum. The positive ES also forward bias the diode and the SCR's gate cathode junction. The positive bias, this is going to be forward bias. The forward bias is a positive input. It's going to forward bias, so it's going to apply the current to the gate. Flow of the gate, that is, gate current will increase as ES increases towards its peak value. So it's increasing. When IG reaches a value equal to IG minimum, the SCR turns on. So when IG becomes IG minimum, then the SCR turns on over this. And EL will approximately equal to ES. That is what is happening. IG minimum comes, EL is approximately equal to ES. Okay. So SCR remains on until ES is approximately equal to EL until ES decreases to the point where the load current is below the SCR holding current. So load current should be IL should be less than IH.
Guys, there is a football selection today at 4 o'clock. Now, who are interested, please to assemble in ground. First, there is a football selection. Who are interested, they can give your name. Selection meeting, you can ensure your name.
Football selection today is the last day. From tomorrow onwards, your names will not be taken. Please come. Not given.
First, throw ball.
Give your name.
What is the activity? What exactly? Anybody interested in VTU sports activity? You can participate. There is a selection is there. So to compete, to participate in video sports activity, they are selecting the students. Only after 4, huh? After 4, okay. After 4, there is selection. Here we have round. Okay. Girls,
No selection, only names.
only names. Those are interested for throw ball. Anybody interested in throw ball? Sports. See, there is one more announcement. Some students are absent. Kindly put a message to them also. They may be interested in sports. In a group, put a message. If they are interested, let them go and meet them by 4 o'clock.
What selection we done?
So let them go and meet them. Or Allah will meet them. Yes. Done? Those who are day scholars, those who are staying in the hostel, day scholars ke kashta agbodu. Those who are staying in hostel or PG, those who are staying in nearby, they can spend the time. They can participate. Day scholars ke athwa college person hoga ke kashta agbodu. Fine. Yes. Now. SCR now turned off and remains off by ES goes negative since its anode cathode is reverse bias and since the SCR is now an open switch, the load voltage is 0 during the period. Second half, SCR is going to be in reverse bias, so it will not work, it will be in the 0 state. Purpose of the diode in the gate circuit is to prevent, see here, why we are using the gate, why we are using the diode. Why can't we directly give the current to the SCR? See here. Assume I don't have the diode here. I don't have the diode. Directly you are passing the current to your IG, that is your gate. It may trigger. There is no control on your IG at all. You have to control the IG. It may go beyond the limit. So I need to control the purpose and since I need to switch on and switch off, I'm going to use the diode over there. If I don't use the diode, always it is on only. Always it is on, so you cannot go for switch on and switch off. So diode is made a gate. The purpose of the diode in the gate circuit is to prevent the gate cathode reverse bias from exceeding the peak reverse gate voltage. So peak reverse voltage should not exceed. Not exceed the peak reverse voltage. It should not go like this. I should not get that one. So to avoid that one, I am going to use the diode in the circuit. This is the second type. RC circuit. R circuit is simple circuit. RC circuit is little bit added. This is also one type of the triggering. We are going to use resistor and also capacitor. Resistor is used, that is R gamma. Capacitor is also used over there. With that one, we are going to use two diodes. We are going to use two diodes here, diode D1 and D2. In the previous circuit, we are using only D1 and only one diode. Here, we are going to use the two diodes for triggering.
Yes. ಕೆಲವೊಂದ್ಸಲ ಬೇಕು ಅಂತಲೇ ಮಾಡ್ತಾರೆ ಅವರವರು. So that their noise or their voice should not disturb me. So then switch on all the fans. They can create the noise on their own, even though it is not cold, it is not hot. ಕೋಟ್ ಹಾಕೊಂಡು ನಾನೇ ನಿಂತ್ಕೊಂಡಿದ್ದೀನಿ, ನನಗೆ ಶೆಕೆ ಆಗ್ತಾ ಇಲ್ಲ, ನಿಮ್ಗೆಲ್ಲ ಶೆಕೆ ಆಗ್ತಾ ಇಲ್ಲ. Fine, come back to the topic business. This is the second type of the triggering. We are using R and C, resistor and capacitor. Resistor and capacitor. See the resistor in its place, it is there. As it is there. Capacitor has been added at the other end of the circuit over there. And we are going to have the two diodes. Almost all the functions, R minimum has been removed. Previously we were having R minimum and R gamma. Now R minimum has been removed over there. Only R gamma has been kept. R gamma is the variable resistance. And we are going to have the two diodes over here. Two diodes are going to be used to perform your triggering, RC triggering we are going to do. Almost
the left side portion is same. This one is same. Because your resistor is there. If we are having a diode, here we are going to use the current. It's going to be power pair is going to conduct and it's going to supply the current. That is your gate current is going to supply over there. So that SCL is going to work. Almost similar to the previous explanation, the same thing is going to work. But we are going to have the capacitor and also the diode over there. Capacitor is used for your charging and discharging. There is a positive plate and negative plate will be there in the capacitor. If it is very small in size, there is no polarities. If the size is bigger in capacitance, that is microfarads, we will be having the polarities like positive and negative in the capacitance. The same thing is going to apply here. So here, the circuit, the waveform is going to be different. We are going to have the triggering as little bit different. It's going to come over there. Where the triggering, where we are going to get the your VAK, it's in different form. Here we are going to get the EL. We are calculating the load voltage. We are calculating there the load voltage during the second half. It was coming here also. It is coming second half only. But as all know that one, it was coming before 90 degree. Your R circuit was working before 90 degree. Here it's going to work from 0 to 180 degree. 0 to 180 degree. 180 to 360 it is 0. 180 to 360 that is your entire diagram your waveform. This is 0 to 360. In one previous circuit R triggering, it was working before 90 degree only. That is the triggering happens before the 90 degree. 0 to 90 degree only triggering is happening over. But in the RC circuit, the triggering will happen in between 0 to 180 degree. Anyway, it can happen over there. That is the difference between your R triggering and RC triggering. So in RC triggering, the triggering is happening almost after the 90 degree is happening over there. See this. This is the alpha, the delay. How much time it's taking for triggering your circuit. Capacitor voltage is keep on increasing. Capacitor voltage keep on increasing. Once it increases, then you are going to get your triggering voltage. That is VGT. Triggering voltage, gate triggering voltage, we'll call that one. Once it reaches the gate triggering voltage,
then it's going to trigger, it switch on your SCR and SCR will conduct over there. So this is where your SCR is going to conduct. As the capacitor voltage is keep on increasing, SCR is going to conduct at this particular value, which is less than your E maximum. E maximum is here, but at this particular value, that is after 90 degree, maybe at 110 or 120, a triggering comes into picture, then only your SCR is going to conduct. So, and when the SCR conducts, your lower voltage is going to be measured here. So, here it is after 90 degree. So, it's clearly mentioned your RC triggering, it works between 0 to 180 degrees. See here, by the RC network, the larger variation in the value of the firing angle can be obtained. Larger variation in the firing angle, 0 to 180 degree. Okay, by changing the phase and amplitude of the gate current. By varying the resistor R gamma, the firing angle can be controlled from 0 to 180 degree. That's what has been given. Firing angle can be controlled from 0 to 180 degree. We can go for it. In the negative half cycle, capacitor charges through diode D2. Capacitor charges through diode D2. So this is going to be charged with lower plate positive to the peak supply voltage. Peak to the peak of the supply voltage. So during the negative half cycle, the capacitor will be charged through the diode D2. Okay. So then only capacitor voltage remains constant at E minus E maximum until supply voltage attains zero value. So you have to see there how exactly this diagram, this whatever is explaining, it is with respect to the waveform over there. Capacitor will be in charging condition only. Capacitor voltage remains constant at minus E maximum until supply voltage attains zero value. So supply is keep on reducing till there it's going to maintain the constant value. As the SCR anode voltage passes through the zero and becomes positive, capacitor C begins to charge through RV. See here. Previously, it was charging through the diode D2. Now it is charging through the resistor R gamma. So sometimes it will be charged through R gamma, sometimes it will be charged through diode D2 itself. During the positive half cycle, it will be with respect to R gamma. During the negative half cycle, it will be with respect to the diode D2. When the capacitor charges to positive voltage equal to gate trigger voltage, that is VGT. What is VGT? VG minimum plus VD1. VD1 is which is connected here. VGT is measured with respect to VG minimum plus the voltage drop across the diode D1. Both put together is given as a VGT, that is gate trigger voltage. So both should be added, then only you are going to get VGT. The SCR is triggered, and after this, the capacitor volts to a small positive voltage as shown below. This is, you can do it. And this is the RC full wave rectifier. Using this, we are able to trigger our SCR also. This is full wave. You know this full wave rectifier, you have studied in your basic electronics. This will trigger. See, this is left side part what we are having. Okay, that is just like your ES. What the ES we are having in our previous circuits, this rectifier will give that particular triggering operation. Remaining circuit, everything is same. Load is there, T is there, resistor is there, capacitor is there. So this is also after 90 degree only you are going to get the triggering. See here, after 90 degree you are going to get the trigger. Even though your input is there, this is full wave rectifier. During both the positive cycles, this, since it is full wave rectifier, both the cycles you are getting the triggering pulse. In the previous case, only one half cycle you are getting the triggering. In this case, you are going to get both the cycles. Since my input is initial input is like this, and using full wave rectifier, I am able to convert that one like this. This is the output of the full wave rectifier. Once this output is applied to your SCR triggering circuit, my EL will become up to here it is 0, up to here is 0, then you are going to get up to here is 0. That means positive half cycle also you are getting the trigger, negative half cycle also you are getting trigger. This is your initial input. Then this is passing through the full wave rectifier. Full rectifier is the output of the full rectifier is this one. This output has been given to the circuit, that is your SCR triggering circuit. So you are going to get this for each half cycle I am getting. That is the difference. Both previous circuit and this circuit, if you compare, in the previous circuit, only first half cycle you are getting the triggering pulse. In this circuit, for every half cycle you are getting the triggering pulse. That is with respect to full rectifier. That is R triggering, RC triggering with your full rectifier. Now is the last topic is UJT. 220, no? Take no issue. Let me explain what is UJT. UJT you studied Mini junction transistor. You not studied transistor, amplifiers and all you have studied, no, basics and electronics. What is UJT? It works as a switch, it works as an amplifier, it can be used for an oscillator. Functionalities. Listen, UJT is basically a switch. It can be used as a switch, it can be used as an amplifier circuit, it can be used for an oscillator circuit, everything is possible. But it is highly efficient compared to your other circuits like your diodes. Diode is also a switch, but UJT is, it works in nanoseconds. See here, in the range of nanoseconds, the triggering, the switching happens in nanoseconds. But in diodes, it was not happening in nanosecond. It was happening in microseconds or even milliseconds. It was happening over there. But UJT is faster compared to your diodes. Since UJT exhibits negative resistance characteristics, it can be used as a relaxation oscillator. That is also one of the functionality. It can be used as a relaxation oscillator. The circuit diagram will be there. Next slide. RB1 and RB2. You know UJT, that is transistor. It looks like this. This is your collector, emitter, base. Okay, we will be having resistor RB1, RB2 here. RB1 and RB2. That is, the circuit diagram is shown with R1 and R2 being small compared to RB1 and RB2. RB1 is towards the collector, RB2 towards the emitter over there. When VBB is applied, when you apply the voltage, capacitor C begins to charge through resistor R exponentially towards VBB. It is charging. During this charging, emitter circuit of UJT is an open circuit. The rate of charging is tau1 is equal to RC. See here, as I read, this is the circuit. We will be having the representation, basic circuit representation of your UJT. Internally, it's going to be like this: RB2 on the top, RB1 is on the bottom. RB1, RB2. Internally, it looks like this. Internally, it looks like that is the symbol. This is the symbol of your UJT, but internally will be having resistors across both collector and also emitter over there. RB1 and RB2. So how the circuit looks, the equivalent circuit looks like that. Means how the current will flow. If I apply the VBB, what's going to happen? Everything has been explained in that particular circuit. This is your internal circuit. This is your symbol. That is this actual equivalent circuit, how it's going to function over there. So here, during the charging, emitter circuit of UJT is an open circuit. The rate of charging is RC. What is the RC value? When this capacitor voltage, which is nothing but emitter voltage, that is VE, reaches to the peak voltage VP, the emitter base junction is forward bias and UJT turns on. So your emitter voltage should reach to VP, that is your peak voltage, then only it's going to be turned on over there. I'll explain how exactly we are triggering the RC trigger, that is UJT triggering, how it will work for the SCR triggering itself. I'll explain that later.